Hello, hello, and welcome to this video. In this video, we will learn more about threads and we'll see try-lock nature of mutexes. So let's revisit our previous program a bit to establish the context. So in the previous program, what main function was doing was that it would read the input and then it would thread was created beforehand, and in the loop you create the input and create the alarm here. This is where we are allocating null for alarm, and then we put this into alarm seconds and message, and then we send this to we add this to the alarm list. Okay, and then this thread which we had, which was alarm thread, will process this. So this alarm list, if you see, it can have more than one alarms at the same time. Okay, it could go to the next alarm and next and next and next. Now, when we are sleeping here, okay, when we are sleeping, we look at the alarm list alarm length. Okay, and the timer of one alarm is being brought down at a time. That means it is processing one alarm at a time. Now, if you remember our previous uh, program to that, that is the multi-thread program where we were creating one thread for alarm every time, and the multi-process one, then you would see that multiple alarms are being processed at the same time. So there is a trade-off between how responsive you want the program to be and how much resources can you afford. Of course, we can't go on creating lots of lamps, lots of processes or lots of threads will eventually cause you to consume all the resources in the system. So that's why we had a less responsive program, but a kind of efficient program in the previous one. Now, what can happen is that in the previous program, we were blocking over the mutex lock. Now we could have situation where we don't want to block and we want to take an alternate execution path, or in other words, we want to try a bit of different logic. Uh, we don't want to block on the mutex locking. We don't want to wait for mutex to unlock. So the function that does that is mutex try lock. Now, as far as the description is concerned of mutex try lock, so mutex try lock, so if you see man3 pthread underscore mutex underscore try lock, so if you see, we have already covered this. We have gone through this man page in previous video. So I won't go again. If you want to, if you are not watched my previous video, it is kind of imperative that you watch it because certain things won't be explained in this video. So what we do here in this program is we have main function, and as you can see, we have two thread IDs, one for counter, one for monitor. So we create counter thread ID counter thread here, and we create monitor thread here. Okay. Then what we do is we join for counter thread and we join monitor thread. So we wait for counter and monitor thread, and then we exit the main routine. Now let's see what monitor thread does. So monitor also something important to note down. End time is time null plus 60, so it is essentially 1 minute. Okay. Now if you look at monitor thread, it has status and misses, and it runs for the same duration, that is up to end time. End time is a global variable here, and counter is also global, and we have a mutex initialized statically. So okay. Now it runs for end time and it sleeps for 3 seconds, monitor thread, and then it tries to acquire the lock of the mutex. As the status is not equal to busy and status of this trial of mutex is 0, then we find the counter. How do we find the counter? Counter slash spin is what we print. Okay. Now, after that, it unlocks the thread and proceeds. Now, what can happen is that it may not uh, be able to get a lock. Okay. In that case, it increases the misses, count misses on the lock. So misses plus plus is done for motor thread. Now, what counter thread does is it also runs for those 60 seconds, and it takes a lock, and it runs for spin where spin is this. Okay, this is 10 million. So sorry, 1, 2, 3, 1, 2, 3. Okay, so it counts for those many spins. Okay, and then it unlocks the mutex. And then what it does is it sleeps for a second. So between unlocked status and locking status, that is when the mutex is free, we have got 1 second. This 1 second is slept so that monitor thread can acquire the lock. So usually you won't see a lot of sleeping when you do real world code, but over here it is done just so that monitor thread can acquire a lock. Once you see condition variables, you will see how we can get rid of this sleep. And by sending signal using conditional variables, we can awaken a thread which is blocked on a lock. So that's the entire logic of this program. So we increase the counter. That is the essence of this thing. And over here we print counter slash spin. Okay, that's that. There is nothing more to it. Okay, so let's see this in action, and we'll see how this works. So we say GCC minus wall minus W error minus S2DV is equal to C23 and minus pedantic space trilog.c, and we have the program, we run it. So it will run for a minute and we see what is the output. So counter is 3. So as you see, if you see the program here, then it sleeps for 3 seconds. Okay. So that's why you will see an interval of 3 most of the time. 3, 6, 9, 12, 15, 18, 21, 24. So it sleeps for 3 and then wakes up and tries to acquire the lock and then prints counter slash spin. Okay, that is what it is printing. So few more seconds and the program will be finished, and we'll see whether we miss any of the motor thread or not. Till now it has not missed anything. The reason for not missing is that the system is quite idle and CPU is free for the threads to schedule as soon as they are ready to execute. So it did not miss any update. Okay. So the crux of the idea is that you don't always want to acquire lock, the thread mutex try lock. By the way, I did not talk about mutex. Mutex is the variable, static variable here, which is the providing us the lock facility. So we don't want always pthread mutex underscore lock because you may have a different logic. Okay, there are certain times where it is okay to skip some of the logic, main logic. So you can try mutex try lock, and the threads will be far more efficient in that case. Also, as I have said earlier, I think in my first video, I said that it is not a good idea to acquire locks and mutexes. The reason is that with high number of thread counts on high number of multi-core CPUs, lock contention is very bad idea. So we should look at thread per core architectures, and the thread communication should be done in inter-thread message passing way. So that's the best architecture you can have for high performance system. These things are being shown to you just so that whenever you see some legacy code, you know what to do with that legacy code. The entire exercise of POSIX is for legacy coding. C now has its own multi-threading primitives or building blocks. C++ also has its own threading model and building blocks. You'll see those after covering the P threads, and then we'll see how we can do multi-threading in C and C++ using the standard language primitives. Internally, they may use POSIX threads, but right now they have their own primitives. So with this, I will end this program here, and I hope that you have enjoyed this program. I will probably add this program to Gist, and I will put the Gist link in the description of the video. Also, I want to draw your attention to my question answer platform, kundika.rustdeveloper.org. And if you see the tags here, then you will see C is one of the tags. So if you have any questions related to C programming or C++, you can join and help me build a community. You can ask your questions here related to C, C++ programming. And if you are an experienced programmer, you can join the community and answer others. So it is a quite new website. Not many users are here. So I hope that with time the community will grow and more people will join. So please do join the community and help like-minded people, and let's share and grow together, share our knowledge and grow together. So that is a request that I have. Usually I don't say to ask to subscribe the channel and like the video, because if you see value, you will automatically do that yourself. So I don't say that subscribe to channel explicitly. So if you see the value, then please join this website and let's interact over here. If you need more tags, let me know and I will add that. So multi-threading could be one more tag which I can add. So with this, I will end this video here, and I'll see you in the next one after 4 days with another program on POSIX Threads. Till then, I will take my leave, and you stay curious, keep learning, and most importantly, enjoy.